Welcome to qnawire.
This question is going to take a look at gas pressures and specifically partial pressures of gases. So we're given some information here that we have 1.25 grams of nitrogen, and that's going to be mixed in with 0.85 grams of oxygen. And we're asked to determine the partial pressure of each of these gases, given these conditions that we're at a temperature of 18 degrees C and the volume of our container is 1.55 liters. The first thing that I did over here, as we run a call with any time we're dealing with gas laws, is our temperature needs to be in Kelvin. So since we're provided with 18 degrees Celsius, I just immediately converted that temperature to Kelvin by adding 273 to it, get our temperature then in a usable form for the gas laws, 291 Kelvin. Now next I tell students to basically use what you're given here. 1.25 grams of nitrogen is what I have, and if I want to determine the mole fraction and partial pressure, I need to know how many moles that is. So from the periodic table, we're able to determine that the molar mass or molecular weight of nitrogen is 28.0 grams per mole. So if we do the math here, so we simply are dividing 28 into 1.25. We end up getting 0.0446 moles of nitrogen, and we're limited to these three significant figures in that answer. If we do the same thing for the oxygen, they tell us we have 0.85 grams of oxygen. From the periodic table, we can determine the molecular weight is 32 grams per mole for the oxygen. Do the division here, 0.85 divided by 32, and we end up getting 0.027 moles of oxygen. And in this case, we're limited to just two significant figures. Now to get the total moles, we're going to have to add these two quantities together. So let's do that next. So in adding the two moles, we end up getting 0.0716 moles total. And based on our addition here, we're limited to the thousandths place. And so more appropriately, the total number of moles is 0.072. So to find the partial pressure of first the nitrogen, we're going to take that 0.0446 moles and divide it by the 0.072 total number of moles. When we do that division, we're going to get 0.619 as our molar fraction, limited to 2 sig figs. So we're going to say more appropriately, the molar fraction of nitrogen is 0.62. Now let's do the same thing with the oxygen. To determine its partial pressure, we're going to take that 0.027 moles of O2 and divide it by the same total number of moles that we have. And when we do that division, we end up getting 0.375, or if we round it appropriately to 2 sig figs, we're going to get 0.38. And notice here that these two partial are molar fractions rather. So this is the molar fraction of nitrogen, 0.62. The 0.38 is the molar fraction of oxygen. They add up to a value of 1, and that's what you want to have happen. And it's sort of a way of checking your math to make sure you've done things appropriately. So if we take each of those two molar fractions and multiply them by the total pressure in the system, we should be able to find the partial pressure of each of these gases. So the next part of the question is utilizing the information that we have available to us along with the ideal gas law to determine the total pressure of the system. We're going to solve for P. So let's figure out what we know. All right, we know that the total number of moles of gas was the 0.072 moles that we determined below. So we're going to plug in 0.072 moles. The temperature we said had to be in Kelvin. That was 291 Kelvin. The pressure is what we're solving for, but they told us that the volume of the container is 1.55 liters. So the last piece of information is R. That's the ideal gas constant. And in terms of the units of atmosphere being utilized here for the pressure units, that value is a constant and it's 0.082 liter atmospheres per mole Kelvin. So the pressure units we're going to determine here are going to be in the units of atmosphere. So when you plug in each of the numbers respectively, and we do the math here, the pressure then in terms of atmosphere, and this again will be the total pressure of the entire system, is we end up getting 1.11 atmosphere for my total pressure, or to appropriately here, as we can see, two significant figures, 1.1 atmosphere. That's the total pressure of the system. Now let's go back down to the problem where we want to plug in that value. So for total pressure in each of these two examples, we now know that total pressure is 1.1 atmosphere. We have everything we need to be able to determine first the partial pressure of the nitrogen, which is going to be that 0.62 times 1.1 atmosphere, and the partial pressure of the oxygen, which is going to be 0.38 times the same total pressure, 1.1. And when we do the math, we find partial pressure of the nitrogen is 0.68 atmosphere, and the partial pressure of the oxygen 0.42 atmosphere. And if we add these two values together, we would get the total pressure that we started with, 1.1 atmosphere. And it's kind of a way of being able to check yourself that, again, you did the math properly here, and that the problem worked out the way you expected.